So here's what you need to know about hyperbolas. The difference between the hyperbola equations and the ellipse equations is hyperbolas have a subtraction sign between the x squared and the y squared, where the ellipse equations had plus signs. So with the ellipses, you decided if it was vertical or horizontal depending on where the bigger number was. The bigger number was always a squared, and that told you where your major axis was, whether or not it was going to be horizontal or vertical. For the hyperbolas, with the subtraction sign, when you subtract, the order matters. And so we have to have the x squared and the a squared first if it's horizontal, and you have to have the y squared with the a squared underneath it first if it's vertical. So the vertex is still a plus or minus a. The covertex is still plus or minus b, and the focus is still plus or minus c. We're really only going to be concerned with the vertex and the covertex today. So let's look at these diagrams so we can see where everything is. So we have the horizontal hyperbola because these arrows point to the right and to the left, so it's horizontal. On the x-axis, we have the vertex, so a and negative a, and the focus. So that's kind of the same as before, except for this time, instead of the x-axis being called the major axis, it's called the transverse axis. And then where the covertices are, the b's, those are on the y-axis, and instead of being called the minor axis, that one's called the conjugate axis. So I know it's a lot of information. I'll point that stuff out on the vertical one. So if you have a vertical hyperbola, your arrows point up and down, like that and that. On the y-axis are your vertex, your a, and your c. All right, it used to be called the major axis, but now we are calling it the transverse axis. And then on the x-axis, you have your covertices, and that x-axis would be called the conjugate axis. So let's write an equation in standard form for each of these graphs. The first thing I notice is that these arrows point to the right and to the left. So it's horizontal, and it means that x squared is going to come first. I know we'll have a minus sign, then we'll have y squared. It'll all equal 1. Our job is just to figure out what's a squared and what's b squared. All right, so a squared is going to come from the x-axis. So let's look at the x-axis and figure out where the hyperbola crosses right there and right there. So it looks like this scale's going by 2s, 2, 4, 6, 8. And since it's halfway between the 4 and the 6, it looks like our a is positive 5 and negative 5. Notice also that this hyperbola is centered at 0, 0, so we don't need to worry about subtracting anything from the x and the y. All right, so a squared is 5. That means a is 5, so that means we're going to square it and plug it in right there. So our answer will be x squared over, if we plug in 5 right here, 5 squared will be 25. All right, now we just have to figure out the number for b. It looks like if this is 2, right there would be 3, so b equals 3. Down here it equals 3 as well. So right here we're going to plug in 3, and 3 squared is 9. So that's the final answer. Same thing on the next one. We have a horizontal hyperbola. That means the x squared will come first. We'll have a minus, then we'll have y squared. And now we just have to figure out what a and b are. Let's see, here and here, 2, 4, 6, 8. All right, so a is 6. So underneath the x squared, we're going to put 6 squared, which is 36. And right here and right here, the covertices, 2, 4, 6. Those are also 6. 6 and negative 6. So when we square each of those, we get 36 and we're done. So this one is a 6x6 rectangle that we have right here. Well, a 6x6 square. So for hyperbolas, it doesn't really matter which way your rectangle is tall or which way it's long or if it's a square. You can't really tell if it's going to be a vertical or horizontal hyperbola from the shape of that box going around A and B. You really just have to tell by which letter is first, the X or the Y. The first thing we're going to decide is this horizontal or vertical? Since the Y is first, this will be vertical. We need the center. The center is whatever subtracted from the X and the Y, and there aren't any numbers there. So our center is at 0, 0. Let's go ahead and plot that. Okay. Now we need A and B. A squared's always going to be first. So we'll square root that and we get plus or minus 5. B squared will always be second. So the B squared is 36. So when we square root that, we get plus or minus 6. So now we're going to count those from our center. In case you forget which way you're going to count, I just remember that the 5 came from underneath the Y. So that means we're going to count up and down 5. The 6 came from underneath the X. So we're going to count that left and right. So from the center, up 5 and down 5. And from the center to the right 6 and to the left 6. And now here comes the fun part. Of course, I think it's fun. We are going to connect those dots with a box. Try to make a dotted line. And once you have that, you're going to connect the corners of the box like that. These are going to be our asymptotes. They're going to be our guide to where we draw the hyperbola. So once you have that all set up, now it's time to draw the hyperbola. I'm going to draw it in green, and we go through our A values. It's vertical, so we're going to go through the vertices on the y-axis. So I'm going to start right there at the vertex, and I'm going to follow the edge of the box and that asymptote. The whole point of the asymptote is that your graph can get close to it, but it can't touch it. Same thing on the bottom one. Think of it like an electric fence for maybe a dog. It can get close to it, but if it crosses it, it's bad. So that would be the final answer for your hyperbola. A bad thing to do would be to draw it super skinny like that. Make sure that you make it as wide as you possibly can without actually crossing the asymptote. We're going to graph this one, but this time we just have to figure out where the center is first because it's not going to be at 0, 0. So let's see, is this horizontal or vertical? Well, X is first, so this one's horizontal. The center will be H, K. Remember, the H is always next to the X, like up here, and the K is always next to the Y. So we take the opposite sign. It was -2, so our center will be at +2. This was +3, so we'll put -3. I'm going to go ahead and plot that, 2 over and 3 down. Next we need A and B. A will always be first. So when we square root that, we're going to get plus or minus 4. And now we'll square root B. B squared is always second, and so we're going to get plus or minus 7. So we need to count those numbers from that center we just put on. Which way are we going to count the 4? It was underneath the X, so we're going to count that to the left and to the right. And the 7 came from underneath the Y, so we're going to count that up and down. So from that dot, I'm going to count over 4 to the right. 1, 2, 3, 4. And to the left 4. And then I'm going to count up 7. 1, 2, 3, 4, 5, 6, 7. And down 7. 1, 2, 3, 4, 5, 6, 7. Now we'll draw a box connecting those dots with a dashed line And now we can make the asymptotes through the corners of the boxes. Try to make your asymptotes all the way across the graph. Now that we have those on, we are ready to draw the graph. I'm going to draw it in blue. I'm going to start at the vertices, which are on the x-axis, these blue dots. I'm going to start and follow the dashed lines, follow the dashed lines. Same thing over here. Well, that's it. I have one homework hint before you stop watching this. My homework hint is, remember when you're finding the centers, that the H is always next to the X and the K is always next to the Y, and you take the opposite sign. So the center in number 5 would be at +2, -1. In number 6, remember the H is always next to the X. So the H is right here and the K is right here. So it means our center will be the opposite of +2. The center will be at -2 and +1. So make sure you get that center in the right spot before you draw the rest of the hyperbola. All right, good luck.